Well, now that you've learned how to correct for a crosswind over a runway, road, or other ground reference, how do you correct for it when there's nothing to follow on the ground, which is most often the case on a cross country? As you may have guessed, this is where you get up close and personal with the wind side of your flight computer. First, check out this side of the slide. It travels up and down, kind of like a trombone. And here on the top, you have directions on how to use the wind side of the computer. Make sure that you see the grid when you're working wind problems, because this grid is essential. But before you actually start working a problem, there are a few things you need to know. Suppose you're planning a flight with a true course of 061 degrees, like the previous problem with the plotter. Then you talk to a weather briefer who tells you that the forecast wind at your altitude is 280 degrees at 30 knots. Note that winds aloft will always be given relative to true north. Now for this problem, your instructor told you to plan the cruise portion of your flight at a true airspeed of 110 knots. You'll normally find the true airspeed for your given altitude and temperature in the performance section of the pilot's information manual. Next, you check your chart and find the isogonic line nearest your course line is 15 degrees east. You also check your airplane's compass card and find a -1 degree deviation error on northeasterly headings. So now let's work this problem and gain some experience determining the wind. Step 1 on your wind computer says rotate the wind direction to be under the true index. For this example, the wind is from 280 degrees true and blowing 30 knots. Rotate the plastic disc until 280 is underneath the true index at the top. That's the wind direction. Next, mark the wind speed up from the center hole. The wind speed or velocity is 30 knots. And while it would be nice if you had a 0 arc here, you don't. You do, however, have a 100 arc, so use it as the starting reference point. Move the inner slide up or down until this hole in the center, called the grommet, is sitting over the arc for 100. Then you simply mark up from the grommet 30 knots. Here's 100, 110, 120, 130, or 30 knots above your reference point. Now, make a cross right here. I found it best to put a horizontal line across the wind velocity and then a vertical line up the center, a cross. And then, just like a treasure map, the cross marks the spot. Actually, on the instructions, the center of the cross is called the wind dot. Now, once you've got that done, draw an arrow from the cross to the grommet. That'll represent the wind direction and the velocity, and it will help vividly depict what the wind will have on your desired course. Step 3 says rotate the true course to be under the true index. So rotate the plastic disc until your true course, which for this example is 061, lies underneath the true index at the top. Once you've got your true course set underneath the true index, you'll move the slide again. Because step 4 says move the slide to put the wind dot over the true airspeed arc. So now move the inner slide up or down until the cross sits on the arc for 110 knots. Now picture your Skyhawk as flying straight up the wind side of the computer, straight up this center line. And this arrow that you've drawn represents what the wind is doing to you. You can see that it's somewhat of a tailwind, so your ground speed will be faster than your true airspeed. Step 5 says read the ground speed under the center hole. As we mentioned earlier, another word for the center hole is grommet. So how do you remember that? Say ground speed grommet 10 times real fast without stopping. So your ground speed is under the grommet, and it reads 131 knots. You see the 130 arc, and we're just one tick above that, so 131 knots. But what does that mean? Well, you already found the true airspeed from the pilot's information manual. If there were no wind, that 110 knots would also represent your ground speed. However, most of the time there is a wind. Fortunately, in this case, you have a tailwind pushing you along. And you can see that by looking at the arrow you drew on the plastic disc. So since the wind is pushing you along, your ground speed is faster than your true airspeed. Now step 6 says read the wind correction angle under the wind dot. You'll notice on the clear plastic disc that the wind is also from the left. So you're going to need a wind correction angle to the left in order to compensate for the wind. The first thing you do is take a look at how many degrees of wind correction angle you'll need. Count the vertical lines to the left until you reach the cross. Each of these lines represents 1 degree. This vertical line is the center, or 0 wind correction. And here's a 5 degrees, and then here's 10. You have 10 lines going over here, and your dot is right here on the 10th line. So for this wind, the wind correction angle is 10 degrees to the left. In order to fly the course 061 degrees, you'll need to crab 10 degrees left into the wind. And the last step says complete the problem using the formula below. The formula this refers to is below the plastic disc right here. The first thing to consider is the true course, which is 061. Enter under true course 061. Then you add or subtract the wind correction angle. And because your wind correction angle lies to the left of the center line, you'll subtract 10 degrees. Wind correction angle, subtract the 10 degrees. And that will give you a true heading of 051, which you enter under true heading. Next, add or subtract the variation which you obtained from the isogonic lines on the chart. In this example, that number is 15 degrees east. And since east is least, subtracting 15 degrees gives you a magnetic heading of 036. Variation, magnetic heading. Finally, add or subtract the deviation for the heading you're flying, -1 degrees for this example. And voila, your compass heading will be 035. Believe it or not, that's all there is to the wind side of the flight computer. And you thought this would be tough.